Okay guys, in this video I will discuss the last type of filter, which is called pi filter. Its alternate name is also pi section filter, or we call it capacitor input filter. Now here is the circuit diagram. It consists of two types of filter. This filter we already discussed in the video before. This is called LC filter, and this is a capacitor filter. So it's a combination of two filter, capacitor filter and LC filter. So it has two components. The first component is C filter, represented by capacitor C1, and the other one is the component is LC filter, represented by inductor L and capacitor C2. Now if I remove this C filter, it's look like LC filter. If I remove this component, then it look like a capacitor filter. So it's a combination of capacitor filter and LC filter. So it has two components. One is LC filter and the other one is LC filter. And its shape is like pi. Its shape is like pi. Pi is like this. So this is inductor and these are the capacitor. So that's why we call it pi filter. Its working principle is very simple. Like the output of this rectifier contain both AC and DC component. Here, once this pass through this capacitor, then this capacitor block DC. So DC will pass through this way, and it allows AC to pass through this capacitor. So the AC component will be grounded. Now might be there is a small part of AC current left with this DC. So once we pass that small component of AC with this DC, then this inductor block the small component of AC and allow DC. So here we have DC with much smaller component of AC. Might be a small AC. Now some AC is bypassed by this capacitor, so here we have a very small AC component here. If it passes through this inductor, then most of that AC variation or ripple will be blocked by this capacitor. So on this side we have more DC current, but might be there is a small AC component also. So once it passes through this capacitor, then this capacitor block DC, so pure DC will pass through this way, while the small variation present here will be grounded by this capacitor. So in the output we have pure DC voltage. So the output will look like this. It's pure DC. This is the working principle of this capacitor. So I have my notes, and I wrote in the notes that first the output of rectifier. The output of rectifier is given rectifier which contain both AC and DC component. Here it contain both AC and DC component is sent through capacitor C1. This capacitor block DC, so DC will not pass through this capacitor and bypass AC component, bypass it, AC component to the ground. Now the DC component which was blocked by this capacitor C1 is passed through the inductor, this inductor, and will easily pass through the inductor because inductor allow DC and blocked AC, and will easily pass through the inductor L because inductor allow DC and block AC. But the small AC component which was not filtered by this capacitor C1 will be blocked by this inductor. Now after passing through the inductor, still there is very small AC component present in the output of this inductor. Now the capacitor C2 of this LC component, LC filter, bypass that small AC component to the ground. AC goes to the ground, which was not filtered by this AC component to the ground, which was not filtered by the inductor. Finally, only DC component will be available at the output load, output resistance. Now the ripple factor, we will calculate the ripple factor. The ripple factor will be, the approximate value of ripple factor of this filter is a combination of ripple factor of capacitor filter and LC filter, which is given by this reason. I can write it here, the approximate ripple factor of this pi filter is combination of ripple factor of, because we have two filter here, one is capacitor filter and the other one is LC filter. So the ripple factor of this pi filter will be a combination of ripple factor of capacitor filter, C filter, ripple factor of C filter and LC filter, given by, so the ripple factor will be of this pi filter will be equal to a combination of ripple factor of capacitor filter times the ripple factor of LC filter. But we know the ripple factor of capacitor filter is 1 over 4 into square root 3 FC1, because this is the ripple factor of capacitor C1. Capacitor is C1, so its capacitance is C1 into RL, which I can write it is 1 over 4 into square root 3, because F is equal to omega over 2 pi. So it will be equal to omega over 2 pi, and we have C1 into RL. If this is equation 1, this is equation number 2. And the ripple factor of this LC filter is given by this relation 1 over 6 into square root 2 omega square L, and we have capacitance, and capacitance is here the capacitor 2, so we call it capacitance of capacitor 2. This is equation number 3. Now using equation 2 and 3 in equation 1, we have, if we put it in equation 1, we get ripple factor of this pi filter, which is equal to the ripple factor of capacitor, which is 1 over 4 into square root 3, and we have omega over 2 pi, and then we have C1 RL times ripple factor of this LC filter, which is 1 over 6 into square root 2, and we have omega square L C2. If we simplify this one, because these 2 cancel with this one, so here we have 2. So if we simplify this, we get pi over 6, 12 into 6 square root, and we have omega and omega square omega cube, and then we have C1 here, C2 is there, so C1 C2, and then we have this L which is given here, and this we have RL. We can write it as gamma of pi is equal to square root 2 into pi divided by 3 into square root 3 into 8 omega cube L C1 C2 RL. If we simplify this one, we get the ripple factor of this pi filter, which is 0.854 over 8. From this I get this value 0.854 at omega cube LC1 C2 into RL. This is the ripple factor. So this is the end of filter circuit. Thank you.